This problem is number 94 on page 645. It is just like 93 that we also did for homework. It is just like example 8 in section 9.3. And I did not write down all the words, but I'll read the words now. A deposit of $50 is made at the beginning of each month in an account that pays 8% interest compounded monthly. The balance A in the account at the end of 5 years is, and then this is given to you. So you can see that the first term has the 50. There's the $50 that's put in at the beginning of each month. The 0.08 represents the annual interest rate, and the 12 is the number of compoundings per month. And because this money is going to be in this account for 5 years, then it'll be compounded how many times in 5 years? Actually, it would be compounded, if you remember the formula, NT, 5 years times 12 compounding, 60 times, which is the last term. Right? The money that's, since $50 is put in every month for 5 years, the money that's put in 1 month before the end of the 5 years is only in there for one compounding. So this is a sum that starts with the exponent of 1. It ends with the exponent of 60. We could write this as a sum. N equals 1 to 60 of 50 times. And we should turn this 1 plus 0.08 over 12 into a decimal. 1 plus 0.08 divided by 12 is 1.007. And that's raised to the n power. Okay, in order, this is a geometric sequence. We're going to use the formula for Sn, which is the first term times 1 minus r to the n divided by 1 minus r. We need to know 3 things: the number of terms. If it starts at n equals 1 and goes to 60, that's 60. We need to know the first term. The first term will be what we get when we substitute the lower limit for n. So we'll have 50 times 1.007 to the first power, which is 50.3. This is 50 times 1.007, which is $50.33. And we need to know the R. And the R is the 1.007. So with all of that, we plug in. S60 equals first term 50.33 times 1 minus 1.007 to the 60th power divided by 1 minus 1.007. And I would definitely put all of that in my calculator. And I need to do this again. 50.33 times 1 minus 1.007 raised to the 60th power. One minus 1.007. There we go. And I'm getting $3,736.90.